Okay, I'm seeing some errors in applying the partial fractions thing, okay? So it really comes down to this. You're okay in doing the arithmetic to well, okay. You're okay in getting things in yeah, okay. Like you've got 2x plus 3 over x minus 4 times x plus 7. And that should be a over x minus 4 plus b over x minus 7. And you get this into its form. You're going to get a plus b times x plus negative 4a minus negative 7a minus 4b over x minus 4 times x minus 7, because y'all are very good at adding rational expressions now, have been since the beginning of the class, and you haven't apparently forgotten how to do that, and that's very encouraging. Okay, doing well with that. Now, what do you do with this? I'm just going to review this once because I've said it several times, so I'm not going to spend a lot of time on it. The denominators are the same, so the numerators have to be the same.
Should it be plus 7 under the B?
I'm sorry, I can't hear, and that's because I didn't put my hearing aid in. But I'll come back and answer the question in a second. Again?
Should it be x plus 7 under B?
X plus 7
Because you have x plus 7.
under B.
Where you have a plus b, and so under a you have x minus 4, and then...
Oh, you're right. I had it right the first time. It should be negative 4 here, negative 7 here, right? I was writing it down, then I wrote it down wrong, thinking I'd done it wrong, and that's only the second mistake I've ever made. Okay?
But shouldn't it just be like a positive 7? Because in the beginning of the problem you have
A
x
positive
plus
7.
Because
Y'all are good at this. You know what it ought to be, so I'm just going to go with what I've got.
Okay.
Now, I think you got to multiply. It's right. Wait a minute. Doggone it. I think I was right, and y'all convinced me I'm wrong, but maybe we're all wrong. I don't know. Should be this, because you're going to have to multiply this by x minus 7 over x minus 7, this by x minus 4 over x minus 4, right?
Yeah, but I was just saying that when you have
The
you have
original.
2x plus 3 over x minus 4, x plus 7, but on the other side you have x minus 7.
Oh,
That's what I was trying to
see,
say.
tell me my denominators aren't the same.
Okay.
I thought we were talking about this thing. Okay, well, that's obviously a minus sign. It just looked like a plus sign because there was a smudge on the board.
Okay.
Okay, now, are we okay?
Yes.
Because I don't want to have to erase that again. Okay. Now, again, all this is mechanical and you do it right. And I think everybody is pretty much doing this correctly, except some people are not doing this. So you're not grouping your x terms and your constant terms, okay? So if you aren't doing that, do it. Okay, it's a step some of you are missing, and if you miss that step, you can't really go on. Okay, and you're kind of missing the point. But the people that are doing that, their algebra is really good, and I think it's mostly people who might have missed a class. So there it is. Now, if this is true, it's got to be true for all x. Every value of x, no matter what x is. If x is 0, if x is 1, if x is negative the square root of 748 pi, whatever, it's got to be true, which means that a plus b has to equal 2. If it doesn't, then there might be some value of x that works, but not every value of x will work. Now I'll let you think about that, but the point is that a plus b has to equal 2, and then negative 7a minus 4b has to equal 3. Now that's two simultaneous equations. And you solve them for a and b. And you rewrite a over x minus 4 plus b over x minus 7 for those values. That's what you do. And if necessary, go back and look at the ones I worked out in class. The videos are all there. Or, go online. Partial fractions. You'll have 78 billion demonstrations. Okay?